Hi everyone, let's look at how to train a machine learning model to predict sentiments from a given textual data. So, this is one of the approaches in sentiment prediction. We are basically using a classifier or text classification. Here in this classification task, the input is the review text and the output or the outcome variable or the target variable is actually sentiment, right? So sentiment is positive or a negative, or it could be more than two category. It could be positive, neutral, and negative. So for the simplicity, we are considering an IMDb data set, which is movie reviews, and then we are using it to train the machine learning model. So this particular IMDb data set is you have a labeled data set which is already present. Labeled data set means text whose sentiments has already been evaluated, usually by a human being. So you have a data set. Let me show you the data set. Um, it's there in the session data session 6. So basically this is the data. So there is an index, there is a URL from where the this is taken. So there is a text which is here, right? And somebody has labeled it, whether it is positive or negative, right? So you have about 2000 um, rows of data, right? 2000 reviews. I think about 1000 is positive and 1000 is negative, and that's your data set, right? So the where is the label coming from? Somebody has done it, right? Sentiment, how do you know the sentiment reflected in the text? Somebody has read it and said this is a positive review, this is a negative review, right? Now the you're asking the machine learning model, you are asking the machine learning model to kind of understand the sentiment, the association between the sentiment, positive sentiment, and the textual data, which is the input, and learn it from the data, right? So you need a supervised ML model to associate such labels to similar text. So, and it is very highly contextual, so you need contextual data. So you are dealing with movie reviews and you need movie reviews. It should be trained in that ideally to kind of understand and predict in a better way. So you need a the kind of one of the limitations of this method is that you need a lot of contextual data, and you need a what do you say, a label data set. Somebody, a human, should actually sit and label. So if it is a cancer prediction, easy thing to understand is a doctor has to label every CT scan as cancerous and versus no cancer, right? So it's a painstaking task of labeling it. So if you are having such data, then the machine learning based approach is one of the best approach. So what do we do is activity 2. So we are having a kind of um, not activity 2, we are going to activity 3. Activity 3, we are taking this IMDb data set, we are kind of using it, we are splitting it, we are using about 80 percentage or 70 percentage of the data to train the model, and you will test it on the 30 percentage of the data and see and report the accuracy measures using these two nodes. We'll see how that is done, right? So I've already loaded this this workflow. So you have the data here. So the data is loaded. So the IMDb data set is your data, right? So then usual steps, first is the document creation. So you string to document conversion. So you can say, yeah, this will not change, URL author. So you're basically, the text is actually the column text, right? So make sure that is there, just run it, and now you're filtering it, right? Only you need what you need, only the input, which is the text, and the output, which is the sentiment, right? So for all the other analysis, the further analysis, so here you are pre-processing it. So they're pretty much the same, I don't have to tell you what is happening. Punctuation, number filter, n character filter means you are removing smaller words, stopword filter, case converter, snowball stummer, all that, right? So then there is, interestingly, there is a shuffle thing, right? Shuffle is nothing but you are just shuffling it before, you're kind of randomizing it before you partition it. So even if it is not there, it will work, but if it is there, it kind of ensures that it is randomly distributed. Now the partitioning node. So partitioning node, I will just show you. We are taking relative about 70% data for the training, and we are using a stratified sampling for using the sentiment what do you say column, right? So for each sentiment we will take a stratified sample. That means the data set will be evenly distributed, right? So you can run it. So basically 1400 data is going to the first partition with the upper arm, and second part is about 600 data points. So it is a 70-30 split, right? Then you do pre-processing. Pre-processing is basically, there are bag of words creator, um, there is bag of words creator, okay? So it's, you now have the term, right? And what is this small red column which is there? It is basically kind of in order to avoid this overfitting problem, so they are taking, so you have found out the terms, okay? These are the terms which are there. Now you are just, this is a way to calculate and remove only those terms which are appearing commonly across all the documents, not all the documents, some documents. So you can, basically what are they doing, they, for the easiness in operation, they are converting this term into string. So every term is converted into string, and then this what you do is you are grouping by. So grouping by is using the term as string, you are manually aggregating and taking how many documents it is appearing. So this is count, right? So it will just count how many times the term is appearing in different documents. So what happens here is you have that count is there. Then there is a row filter, so which says you will put a lower bound. So the terms appearing at least five documents, the term which is appearing in at least 5 documents will be allowed, and rest will be filtered out. That means, that makes sense, right? It's like, I want a term which is relevant term, not every term, so that later the model fits to the training data, but when it comes to the general testing or other new data, it doesn't operate well. So in order to avoid this problem, I'm kind of making it more general. So a better model is more general model, which is not overfitted to the training data set. So this is one way to do it. um, you could change it, this 5 you can change it to 20 or 10 and see what is the change in the accuracy levels. So finally there is a reference row filter. Basically it takes it compares the two incoming streams and only copies the common um, element. So in that way you will have only the terms which appear in 5 documents which are moving forward, right? So then it is term frequency. So we have done the pre-processing. Basically you've converted into the bag of words, and now you will convert into a vector. So now what is the difference? Every word is taken as a variable or a feature, right? And you have document here, and about 3670 words are there, right? Which is the input variable, right? The text is converted to a number now. Now this is now if you look at the output of this, say column filter, I'll just show you what is there. I'll just show you what is there. So control A, let's pull it back. So here you have all words are there, okay, and the document file is there. So ideally words are the input, so I don't have um, the the output variable. So in order to do that, so you apply something. This is very similar to the document extractor node which you have seen. So this, what it does is it goes to the document, and in the document there is a category of the document which is metadata of the document. So category we have put the sentiment. So I'll show you here. In category, while making the document category, you have put sentiment. So I want, so sentiment is our um, class to be predicted, so I want that to be fetched. So this will do that. So it will basically add a so here you had 3671 columns. Here you will have 3672, which is the new column is actually the sentiment, which is your output target variable. So then color manager is just for display. You can select from whichever list, either select a default or you can go and customize it here. So I've selected red for positive, sorry, green for positive and red for negative, and then you give it to a decision tree learner. So decision tree learner is taking so it is predicting the document class, which is the last target variable, right? And it is using all these methods. So Gini index, or you can change it to gain ratio, because if, Gini index is gain ratio is better predictor, the C5 decision tree. Pruning, then other things remains the same. I'm not going to change any of that. Okay. And so let's see what it does. So this is how it does. So this is the output. So when you have, so we started with 700 unequal categories. So now when you find the word bad, immediately it is almost 91% is negative, right? So then it checks the other kind of words and further splits. So here waste, that means almost 100%, 101 reviews are negative. When you find the word waste, it is immediately stopping there, right? The classification is done. Similarly, Excel, so it's predominantly positive. So similarly, it goes bore, I'm bored and all, that's the word. So basically this is how the splitting goes, and the rule is along the branches. So you can stop it at some level, because beyond further splitting is not required after it reaches a particular level. So but this is how the logic. So basically if it finds, it first checks whether there is a word called as bad, then it is almost very sure that it is a negative, right? If it is not there, then it check the other things. So it is if you remember, the coded was 0 and 1. If you split it, less than 0.5 is actually 0, and which is the word is absent, and greater than 0.5 is 1, which is the word is present, right? That's the logic, right? So now you apply the same for the 30%. You just apply it. Document vector, this is a document applier, is basically you are taking that model and applying it to the incoming data set. So you apply it because you want the same word scheme to be used for vectorization. So all the other things are same. You apply the decision tree predictor, the model is coming through this line, the equation is coming through this line, and you're just applying it to the incoming stream. Incoming stream, where is the incoming stream? The second partition, 600 data points are here, right? Now this is what you get, and what do you get in the end? So we can take it out and see what is being generated. So document, just shift document, and document class and predictor class, just see. So yeah, so there is the prediction, this is the original class, this is the prediction. So basically scorer actually compares these things. So about 91% accurate. These are 30 and 20 cases, 50 cases are misclassified, but pretty much accurate model. Then ROC curve is giving you a visual examination of the accuracy 917, which is also fairly good, right? So you might have to